Imagine you're a lotus flower. Now, lotus flowers don't typically come from clean waters. They usually arrive from very dirty, murky, grimy ponds. Yet, the lotus flower is known in Japan, in Egypt, as being a symbol of rebirth, of reawakening, as something beautiful and sparkling coming from an origin that is not. How is this possible? How is a lotus flower able to maintain its cleanliness despite being from such a dirty area? And the answer lies in superhydrophobicity. And superhydrophobicity is when a surface has both micro and nanostructures that repel the water and prevent it from wetting the surface. Wetting the surface is when the ability of a water molecule to interact with the surface, and as a result, there are intermolecular forces that happen as soon as the water molecule and the surface touch. But micro and nanostructures on superhydrophobic surfaces keep a layer of air in between the water molecule and the surface, therefore preventing those intermolecular forces from occurring. So how does this work in a lotus flower? When a water droplet either condenses or falls on the lotus flower, instead of wetting the surface, it will beat up in a sphere and then roll off, and it'll take any excess grime and dirt with it. And so the lotus flower has then a self-cleaning mechanism, and this is called the lotus effect. And this is seen in nature with penguins, with hydrofuge on the insects that can walk on water. And so what makes a surface superhydrophobic as opposed to just hydrophobic? And the answer lies in those nanostructures that are then also on top of these microstructures. See, here's a picture. There's a water droplet, right? And then there is the microstructures and the nanostructures. But what's significant, the numbers-wise, is that the contact angle, which is from the very bottom of the water droplet around to the edge of the curvature of the water droplet, has to be greater than 150 degrees. And that's what makes a surface superhydrophobic. And there's so many applications that can be used with superhydrophobicity. They're making coats that repel water, and so those will be the most effective raincoats ever. There can also be swimsuits that will make swimmers a lot faster. Also, there are these micro fuel chips that are being made that have the ability to then funnel out carbon dioxide through these superhydrophobic channels while keeping liquid fuel inside the chip. Superhydrophobicity has a slamming future, and I'm so excited to tell you more about it later.